See, this is the question in from paper June 2021. How can we solve it? In this, they said node voltage equation means we have to do it by using nodal analysis. In this, we are having three node. Let us consider this one as VA, this one as V, and this one as V. We can mark the current randomly I1, I2, I3, then I4, I5, I6, and then I7, right? So tell me the equation at node A, Kirchhoff current law. Which current is entering and which current is leaving? Tell me at node A. Which current is entering? Hmm? I3 is entering now. So I3 is entering and I2 and I1 are leaving. Correct? Now can anyone tell that what is the value for the I3? I3 is moving from ground to VA, right? So it would be how much? 0 minus VA, and we have to take the second sign of the battery. Second sign of the battery is plus 2 divided by the resistance. Resistance is 1 ohm, correct? Now I2 is moving from VA to VB, so that would be VA minus VB divided by 2. Now I1 is moving from VA to VC, so that would be VA minus VC. Again, the second sign of the battery, that is plus 12 divided by the resistance 6. Correct? Now similarly, we'll apply Kirchhoff current law at node B. Node B, two currents are the incoming current, I2 and I6 are the incoming current, and I3, I4 and I5 are the leaving current. Correct? So I2 is again the same, that is VA minus V divided by 2. I6 is how much? They have given directly 2 ampere. I4 is VB minus 0 divided by 3. And I5 is how much? VB minus VC divided by 4. Right? Similarly, we'll apply the equation at node C. Node C, I1 is incoming, I5 is incoming, I6 and I7 are outgoing. So I1 plus I5 is equal to I6 plus I7. We know all the values, but I7 is how much? It is moving from VC to 0. So that would be how much? Tell me.